Alright, so in the last lecture I shared with you guys a pro tip that basically said never calculate rates or rate metrics in your raw data itself, and to instead make those calculations using pivot table calculated fields. Now it's a bit of a nuanced point, but it's an important one, and I think it's worth digging into a little bit more. So let me give you guys a demonstration of why this is so important and what the implications are of taking each approach. So in this case, we already calculated a field called ROI, which is calculated as the revenue divided by the budget. Now that's a good example of a rate metric. So had I instead gone into my raw data and inserted a brand new column here, I'm going to insert it right after Q and call it ROI raw, I could just calculate that right in here as column Q divided by S, which is budget, and apply that down. I don't want to mess up the formatting, so I can go into the autofill options, fill without formatting, and I can just turn that into percentage, really just to draw attention to the fact that this one column, column R, is a calculated rate, whereas all of my other columns are counting or volume metrics. So with that, I can jump back to my pivot, go into Pivot Table Tools, hit refresh, scroll down, and I can see that new field, ROI raw. And when I drag that in, the sum of ROI raw doesn't really make any sense because you really don't want to add up percentages. So what we're going to do is change this to the average and press OK. And then when we format this as a percentage with no decimal points, you'll see that we get the exact same values that we got using the calculated field version of ROI. So you might be saying, what's the point? This is great. I'm getting the same answer. Why can't I take either approach? And the answer lies in how we're viewing the data. So right now we're looking at this data at the title level, which if you remember, our raw data is at the title level. So this is the most granular view we can get. There's no grouping and no aggregation happening here, so that there's really only one number in the raw data that's populating for each title, since each title only populates a single row. So in this case, it really doesn't matter if we view this as a sum, an average, a min, or a max. It's going to give us the same data because the max of one number is equal to the sum of that one number is equal to the minimum of that one number, and so on and so forth. So if you're looking at data with no aggregation, then in that one particular case, it doesn't matter how you calculate the values. The problem arises when you start grouping and rolling up and slicing and dicing your data. So instead of title, we can pull that out and drop in something like country, for instance. Now all of a sudden you start to see these differences, 113% versus 99, 144 versus 172. And the reason why we're seeing these differences is that the average of ROI raw is just taking a straight average of any ROI numbers that fall into this bucket, whereas our calculated ROI is recalculating based on the budget and revenue numbers generated by any view that we're creating in this pivot table. So it's properly weighting those values and returning the accurate measure of ROI. So you'll notice that in some cases, typically countries with a low number of titles in the raw data, we get an exact match, like Indonesia and Iran, but others that have more data points in our sample, like the UK and USA, are showing much more significant discrepancies. So this same logic applies no matter what kind of calculation you're making. The key point is that your raw data should only contain those counting or volume metrics, and any sort of rate calculations should be done right here in your pivot table using those calculated field options. So with that, let's go ahead and just delete this column. Don't want to confuse things. We'll go back into our pivot, pull this out, and just do a quick refresh. And now we're back kind of to where we started with. So hopefully that helps shed some light on why that pro tip is so important and why calculated fields are so important when it comes to data accuracy and data quality.